Okay, everyone, so this lesson is going to be really short because most of it is just reading through the instructions and graphing the things out on your calculator. Now, remember, if you have a Casio calculator, it's going to be a little bit different. You're going to go into the menu, you're going to go into your graph function, and then you're going to put all of your information in that graph function. When you are solving anything on the graph, then you're going to look up at the top, and I believe it's F4 for calculate. And then the only difference is when it's talking about like zeros, it's going to be roots, but for the most part, it is the exact same thing. So you might have to play around just a little bit to see how this works. So I'm going to skip past a good chunk of this because it's mostly just you reading through and trying things out on your calculator, making sure that what you put into your calculator matches what you're seeing on the screen. And we'll get to the first example. Now, for the first one, if you're graphing the equation y is equal to 2x minus 25, and you're doing it properly on your calculator, well, you could have a number of different settings, but the settings that I'm going to use are going to be negative 10, positive 20, and 5. And for y, negative 50, positive 30, and 5. So it sort of matches what the graph looks like here, and I can see both of my intercepts. I'm going to graph it out, and it's going to look something like this. And when I use the graphing calculator to determine the value of y when x is equal to 4.5, then I can just put in the 4.5 enter or trace 4.5 enter, and I'm going to see that y is equal to negative 16. If you do the trace function, then it's just going to come in somewhere around this point here. If I'm algebraically verifying it, I'm going to say that y is equal to 2 bracket 4.5, using the brackets when we replace a variable, minus 25, or y is equal to 9 minus 25, y is equal to negative 16. If I'm using the graphing calculator to determine the value of x when y is equal to negative 6.4, then that's where I'm going to put in a second equation in my calculator. So the second equation is going to be y is equal to negative 6.4. When I graph that out, then I'm going to have a graph where a second line is coming through along here, and then I'm going to solve for where they intersect, and at that point I'm going to find that x is equal to 9.3. If I algebraically verify it, negative 6.4 is equal to 2x minus 25. Put brackets around the negative 6.4 to show that I replaced a variable. I'm going to add 25 to both sides and get 18.6 is equal to 2x, and when I divide both sides by 2, x is equal to 9.3, and that one all makes sense. Okay, here it's talking about the intercepts. Remember that in the TIs it's going to say zeros, in the Casios it's just going to call them roots. Still going to be doing the same process. When you do it, then for example 2, in each case, use the features on a graphing calculator to calculate the x and the y intercepts of the graph. Well, if you're doing this properly, then the x-intercepts for the first one should be negative 3, and the y-intercept is going to occur at 5. If I'm doing example B, then the x-intercept is going to be -2 or +3. It actually happens twice, so you got to solve them twice. And the y-intercept is going to occur at 6. Okay, so like I said, for this one, mostly, if you're struggling with it, just play around with your calculator, try the functions.